cases. Okay, so I want to put it this special cases, just give an example. So number one, we have the two following equations. So we have 9x minus 9y equals 5. And the second equation is negative 36x plus 36y equals negative 15. Okay. So we covered three methods. The two first methods is the addition method, where you added both sides of the equation with the goal of eliminate one of the variables. So before that, you have to do a little modification of the equation sometimes, and then you add left side to left side, right side to right side. And then you're supposed to have just one variable after that. The other method is the substitution. So you work with one equation, isolate the variable, and then plug in that expression of the variable in the other equation that you didn't use yet. So by doing that, you basically eliminate also one variable and solve for the other. So when you look at this example number one that I wrote in my pad, it's best that we do the addition method, for the reason that if you decide to isolate a variable in any of the two equations, it's going to create fractions. So we want to avoid the work with fractions. Instead, I want to multiply, for example, the first equation by a number where it's going to either make my x variable or my y variable, I choose which one, disappear. So for example, if I'm focusing on x, it means I want to cancel x. So I look at the numbers I have in front of x, right? So I have 9 and I have negative 36. So I want it to be opposite numbers, the same number, but one plus and the other minus, well, of course. So opposite numbers in front of the variable x. So when I add the left sides of my equation, then it's going to be canceled. Since I have 9 and negative 36, 9, if I multiply by 4, I get positive 36. So I'm going to change my first equation to do that. So my first equation, I'm going to multiply by 4. Everything. Even though I only want to cancel x, I multiply everything by 4. So if I do that multiplication by 4 into my first equation, so 9 times 4 is 36, so 36x, and then I have negative 9y, so if I multiply by 4, I have negative 36y. Now 4 times 5 on my right side of the equation, 4 times 5 is 20. Now I'm not changing the second equation, so it stays exactly the same. And even though I want to cancel only x, you can see the way that my equation is going to end up canceling both x and y, okay? So when I add left side to left side, both x and y, I cancel because I have opposite coefficients, the number in front of those variables. So they add up to 0, right? So you have 0 plus 0 there. I don't need to put the 0. I'm just demonstrating that when you add the x terms, that's 0. When you add the y terms, that's also 0. So 0 plus 0 is 0. Now, when I add the right sides, which I can do is just number, I have 20 plus negative 15. So that is 20 minus 15, the same thing, which is 5. Now, I got in a statement, so there's no more variable, not x, neither y. And I have a statement that says that 0 is equals to 5, which is a false statement. Right? Meaning, doesn't matter what I try to do to solve this, even if I use the other method, or if I use, for example, the graphing for solving. what I have here is that a false statement means that I'm not able to solve at all this. It's impossible to solve this. There's no solution. So there is no solution for the system. Okay. So if I need to write a solution set, I would write that my solution set is the empty set. Right? So I can either write like that, or the other way of writing the same thing is with the empty curly braces notation, right? That set builder notation. So I have no element, no order pair that satisfy both equations. It's just not possible. So this is a special case. If I were to graph to solve this system of equation, and we did the graphing last Wednesday in the class, the Math 10 part class, what I was looking at, and I believe I mentioned briefly, is that I have two parallel lines. So it doesn't mean that this is my graph, but I would have something that looks like that. So I have the graph of an equation 1, and I have the graph of an equation 2, and because they are parallel lines, let me fix my typo there. Parallel lines, they never meet. And if they never meet, there's no common point or points that satisfy both equations. So I have no solution. Okay, so we can see this visually as graph, as parallel lines, meaning no solution. But when we're trying to solve this algebraically, any method, okay, doesn't matter the method, you would get some false statement from that because both variable will be canceled. And then what you have is that a number equals another number, which is not true. Then you have an impossibility of solving the system, therefore there is no solution. My other example that I would like to cover now, number 2. I have two equations again. The equations are 2x minus 6y equals 6, minus 12y equals 12 minus 4x. Okay. So we're going to solve now this equation again. Any method works. Just see what's the best for you. So I'm gonna just move a little bit upwards here. I could solve the first equation for x. It's not gonna be fractions because I see that 6 can be divided by 2, because when I try to isolate x, I divide by 2 everywhere. So 6 can be divided by 2, so that's why I'm not gonna have any fractions. So I can do the elimination method. You can also do the addition, no problem at all. Okay. So let me do the addition. I will actually show both ways because this is an interesting way that the equation is. Right now we have in the standard form the first equation. Let me put the second equation in standard form, meaning I'm going to move the negative 4x from the right to the left side. So my second equation, we're going to adjust. So to adjust means, okay, I'm going to move the 4x to the right, to the left. I'm sorry, to the left. So now my equation is going to look like this. My second equation is 4x minus 12y equals 12. So now my system is 2x minus 6y equals 6. And then my second equation in the other form is 4x minus 12y equals 12. Okay? Because I want to do the addition method. So let me put here that this is the addition method. All right, so in order to cancel either x or y, I have to modify at least one of my equations. So if I multiply the first equation, let's say multiply by -2, okay? My first equation will look like this: -4x plus 12y equals -12, okay? The second equation I want to keep exactly the same. So for x minus 12y equals 12. And now I add the left side to the left side, right side to the right side. I'm sorry, I missed the... Okay, I found my screen. And when I do that, you can see that both x and y variables are canceled because they are opposite. So the result is, again, 0 plus 0. And then when you add the right side, I also have opposite. So that's another 0. So this time I got also a statement, but this is a true statement. It's always going to be true. And because there is no variable to solve for, and it's a true statement, it means basically that both equations are actually the same equations in a different form. And if I have the same equation twice, the points of that equation is actually the solution. So I have infinitely many solutions. Many solutions. And the way we write the solution set, because we do have solutions in this case, right? It's true. All the order pairs, x and y, that satisfy the equation, because it is the same equation. It's just the way we see in that equation. One can be considered like simplified with the numbers and the other not, but it is the same equation. So pick one of the equations there. Let's say the first one. So we're looking for all order pairs, x and y, that satisfy 2x minus 6y equals 6. Okay, so that's how we write the solution for the system that has infinitely many solutions. And it comes down to be either true or false statements, right? So if it's true, infinitely many solutions. So the solution set is all order pairs that satisfies the equation, because the two equations are actually the same line when you graph. So you would have your graph, and then line 1, equation 1, correspond to the same as equation 2. So they coincide. So equation 2 and equation number 1, they are the same. Okay? And because that every single point satisfies the system, and we have infinitely many. If your statement after canceling both variables is false, you don't have a solution, right? So that is the other case that we saw above. The lines are parallel. All right, so I said in the beginning of example number 2 there that we could solve this also without creating fraction using the other method. So let me write on the side the other method. So now I'm going to do the substitution method. And let me write again the same equations as I had in the beginning. 2x minus 6y equals 6. And then I have negative 12y equals 12 minus 4x. Okay, so that's exactly the same example. But I'm going to solve this time by the substitution method. So it means I needed to isolate one of the variables, as I mentioned. Variable x, we're going to isolate x in the first equation. That means I have 2x minus 6y equals 6. To isolate x means get rid of 6y by adding that on both sides. So we have 2x equals 6 plus 6y. And then divide everything on both sides by 2. So this is x, and then you have 6 divided by 2 and 6y divided by 2. As I said, we can divide 6 by 2 and the result is 3. So this is 3 plus 3y. Now this is x, and this coming from the first equation. Let's put that now in the second equation. So I'm going to put here. So when I do that, I have minus 12, just a second, let me make this more visible, minus 12y equals 12 minus 4 times whatever x is from the other equation, and that is 3 plus 3y. Okay, now I'm going to solve for y because there's no more x. Don't forget I have to distribute. Negative 4 multiplies everything inside that parenthesis. So I have negative 12y equals 12, and then multiplying negative 4 inside the parenthesis give me negative 4 times 3 is negative 12, and then negative 4 times 3y, negative 12y. All right. You can see that like terms on the same side of the equation can be canceled there. I mean, 12 cancels negative 12. So right now I have negative 12y equals negative 12y. If you decide to move any of this, but right now I already see the answer, right? Because it's saying negative 12y is negative 12y, which is already a true statement. But let's say you didn't see that, what you're going to try to do is to add 12y to, for example, move from left to right. When you do that, you have 0, and also you have 0 again. This is a true statement, right? Like before, the other method, because I got true statement, and by the way, it doesn't need to be 0 equals 0. It could be 5 equals 5, 10 equals 10, minus 30 equals minus 30. Whatever results from your cancellation, that's okay. But it happens that in both cases, the way I did, it comes out as 0 equals 0. So when you get a true statement, regardless of what is the number, it just say a number equals itself. This is true statement. We have infinitely many solutions, therefore my solution set is still the same, right? It's just a different way of getting the same answer.